Okay, hello everyone. In this third example, I'm going to show you how to find the area above the positive or negative scores of Z. Okay, so let's say that you are interested to know how many percent of students scored greater than 85. So we are finding area above the particular score, above than 85. So what is the percent of people scoring greater than 85 with a given mean of 70.7 and the standard deviation of 10.27. As usual, our first step is to convert the raw to the Z-score. What is our raw score? Raw score is 85. So 85 converted to Z. 85 minus the mean divided by standard deviation, you get 1.39. So when you plot it out, so middle is your mean, goes to 0, and the Z-score is 1.39. So what did we say? Has to be greater than 85. So greater than 1.39. So this area is the greater area. So we look at the table. So in the table, we will look for the proportion of probability of the Z-score greater than 1.39. So in the table, it will be on the column C because we want to find the area greater above. So if it is negative, it will be below. But we will still find 1.39. Let's say it gives negative 1.39. You plot it in this area. So greater than 1.39 here. So in this value, it is symmetrical. So you can still find the area for 1.39 and then you can convert it. Okay. So for greater than 1.39, in this case is going to be 0.0823. So and then we convert that proportion into percentages, it becomes 8.23. So only 8.23% of students scored greater than 85. So that makes sense because when you get smaller and smaller, when the curve gets smaller, remember they are becoming in the extreme groups, far from the mean. So not many people will score higher than the average students, right? So average is what? It's the representative. So basically, on average, we have a person with 70.7. So 85, it is like on very few people, like very extreme kind of people scoring 85. So we want to know greater. So it becomes smaller. Not many people will get 85. Right? Not many people will get 95. There are only a few that really understand the concepts, or maybe they are really smart. So what we're trying to say here is when it becomes greater than and far from the mean, the area becomes smaller. So that's why if you notice, the proportion or the probability values were smaller. Hope it was clear. Thank you.